Hi, I'm Alex McColgan and you're watching Astrum. As you may or may not be aware, NASA launched the Juno probe in 2011 to go into a polar orbit around Jupiter. Jupiter doesn't have any probes in its orbit at the moment, the last one being the Galileo probe, which was purposefully crashed into the planet in 2003. The Juno probe is expected to arrive in only a few days, on the 4th of July, exciting stuff indeed. But what's it going to be doing in orbit? Well, by the end of this video, you will know everything you could want to know about the Juno probe. So let's start from the beginning. As far as NASA missions go, it's a medium budget project with total expense expected to be about $1.1 billion over the course of its mission time. Now this is a large probe, because unlike previous probes we've sent out that are powered by radioisotope thermoelectric generators, it's powered by solar panels. But these panels have to be big because it's only going to get 4% of the sunlight it would if it was around Earth. In fact, it's the furthest out we've ever sent a solar panel probe, ever. But because of the size of the panels and the improvement in solar panel technology recently, this should work just fine. It was launched on the 5th of August 2011 using an Atlas V rocket. Escaping Earth's atmosphere and entering orbit is one of the most risky parts of the whole mission, but everything went smoothly, and less than an hour after liftoff, it was already on an escape trajectory from the Earth. Juno's journey to Jupiter is an interesting one, as after it escaped Earth's gravity, it headed into deep space. At this point, it did a small burn using its engines and headed straight back to Earth, reaching it 2 years after it had first launched. You may wonder to yourself why it would do that. Well, the answer is very clever. When Juno reached Earth again, the gravity of Earth started pulling Juno towards it. This gravitational influence increased the speed of Juno by over 14,000 km per hour, slingshotting it at top speed towards Jupiter. This method is more fuel efficient than burning the probe's engines to get there. Like I said, Juno will arrive at Jupiter on the 4th of July, where it will adjust its trajectory until it's in a polar orbit around Jupiter. A polar orbit means it will orbit around Jupiter's poles. Again, this is one of the most dangerous times of the mission, as the trajectory needs to be just right for the mission to be successful. If everything goes well, it will do 2 53-day orbits before performing another burn, bringing the orbits to only 14 days long. At its closest approach to Jupiter, Juno will only be 4,300 kilometers above the Jovian atmosphere. Being this close to Jupiter is a big problem as far as delicate scientific instruments go. You see, Jupiter has an extremely powerful radiation belt around the planet, easily powerful enough to fry most electronics, and being this close to the planet means Juno will go straight through it. This is why the expected mission life for the probe won't be over 20 months in orbit, with some instruments not expected to last beyond the first 8 to 9 months. To try and prolong the inevitable, Juno is surrounded by a 1 centimeter thick layer of titanium to protect the internals from frying. It's kind of like a tank going into space. But whether this will be enough or not will soon be proven when Juno enters orbit for the first time. So what about Juno's mission? Well, in a sad kind of way, it will not be turning its attention to any of the moons, but will rather be focusing on Jupiter itself. It will be measuring the amount of water in Jupiter's atmosphere to determine which planet formation theory is correct. It will look deep into Jupiter's atmosphere to measure composition, temperature, cloud motions, and so on. It will also map Jupiter's magnetic and gravity fields. We already know the magnetic field of Jupiter is hugely interesting due to its strength and size. Did you know, for example, if the magnetic field of Jupiter was visible in our sky, this is how big it would appear. Juno will particularly explore and study Jupiter's magnetosphere near the planet's poles, especially the auroras. Jupiter's northern and southern lights provided new insight how the planet's enormous magnetic field affects its atmosphere. Just lastly, you may be interested in how Juno got its name. Well, it comes from the Greco-Roman mythology. The god Jupiter drew a veil of clouds around himself to hide his mischief, But his wife, the goddess Juno, was able to peer through the clouds and see Jupiter's true nature, an apt name for a mission to look deep into Jupiter's atmosphere. Well, thank you for watching. If you enjoyed this video, then you may like my planet series, where I explain everything you could want to know about all the planets in our solar system. Be sure to give the video a like and do subscribe if you want more. And to my subscribers, I will see you next time.